Hello everyone, my name is Gurnoor Singh and welcome to my tutorial, a deep dive into QUIC protocol. In this video, I'll explain what QUIC is, why it was developed, explore its architecture, discuss real-world applications, analyze its hands-on using Wireshark, and finally look at scalability and key takeaways. So, what and why is QUIC? QUIC or Quick UDP Internet Connections is a modern transport protocol originally developed by Google in 2013 and standardized by IETF in 2021. Its main goal is to make internet communication faster and more reliable by reducing latency and connection setup time. So let's understand why QUIC was needed. Over here, you can see in this diagram as well that traditional HTTP over TCP involves multiple handshakes. That is, TCP requires a three-way handshake and then TLS setup is required before any data can even start flowing. Quick eliminates this delay by combining transport and encryption into a single step. So what happens is that it runs on UDP and supports one round trip time and even zero round trip time handshakes. So only one round trip time is or one packet delivery is required in order for the handshake to even complete. With zero round trip time, if the client has connected before it can send encrypted data immediately without waiting for a new handshake, this drastically reduces latency and helps in much more faster network communication as well. And if we move further and explore what are the more reasons or further reasons that are that the Quick was developed, I will just move this slide further and yeah, explain the head of line blocking as well. So within what head of line and blocking and security, uh, in TCP data is delivered as one of the continuous stream. So if one packet is lost, all subsequent packets wait. QUIC multiplexes streams within a single connection. That is, each stream is independent, so packet loss on one doesn't affect others. QUIC also improves security by using TLS 1.3 version, which is built directly into the protocol. So what that means is that every QUIC connection is encrypted from the start, unlike TCP actually, which adds encryption later. And this integration simplifies setup and improves protection against attacks as well. And so, yeah, that's why we require this much more than anything else, I would say. And if we move on to the next slide, you have the architectural deep dive, which within which what we're going to do is actually look at functionalities and formats of this protocol. On the functionality section, each connection has multiplex streams, allowing multiple conversations in one connection, which we just discussed now. Integrated TLS 1.3 encryption ensures confidentiality and integrity as well. So yeah, already discussed. Then you have reduced latency through one round trip or zero round trip handshakes. And you further we look into it, we have connection migration uh, using connection IDs independent of IP or port. So this is something that is very ideal for mobile devices as well, because what happens is as mobile devices are constantly switching between networks, it can be Wi-Fi to their own device network or something else. Each the connection doesn't have to be established again actually, and the IPs can be stored and internet can run as usual without any intervention just because of this connection migration feature. Afterwards, we have better acknowledgement of ACK frames, which we can see here that quick frames are much more flexible. That's why. So you have stream frames which carry application data. Then ACK frames acknowledge these packets which are sent. And then we have the crypto frames which carry encryption handshake data. So that helps a lot as well. And then ping frames checks path connectivity. So yeah, overall, these frames and formats, along with the functionalities, help this protocol run much more smoother than anything else. And if we dive into where this protocol is used, it's all over the modern day applications now. QUIC is now widely used by major internet services. Google search, YouTube, Gmail all rely on this for speed and stability. For example, YouTube experiences fewer buffering issues thanks to multiplex streams. Gmail connections rely on unstable Wi-Fi because Quick can migrate connections seamlessly. More real world use data sorry more real world use can be found in, I guess, in next slide. If we look into meta applications as well. So something like Facebook and Instagram use Quick to feed images and videos are delivered on separate Quick streams, which make pages load faster. And then you have messaging benefits from lower latency and fewer drop packets, especially on mobile networks with frequent packet loss. Apart from that, we have security and scalability as well. Uh, in terms of that. So in terms of scalability, Quick improves extremely well because multiplexing removes bottlenecks. Servers can handle many parallel requests efficiently. Afterwards, you have the use of connection IDs, which allows connection to persist even if a user's IP address changes. So again, a big advantage. On the security side of things, Quick faces a few challenges. That is replay attacks in zero round trip time, or even amplification attacks during initial connections, but these are mitigated with strict authentication. As we discussed before, that TLS is built into the protocol, so each connection that is being developed is already encrypted. So uh, since the whole protocol is encrypted by default, that risk is mitigated. Afterwards, what we will do is now move on to much more practical side of things, and we will do that by going to the Wireshark and seeing how it works. So let's just move from here. So Wireshark analysis. Yeah, stop the screen sharing. Share. Yeah, this one. So over here, as you guys can see, now what I did was I cleared my cache into my browser and then searched for YouTube, which is a Google service. And these are the QUIC packets that I have received after doing that. And over here, that's the initial packet that was sent to the server from this device. So you have the frame, of course. Then we have Ethernet connection being set up, destination source IPs and stuff. Then we have Internet Protocol version 4, IPv4. Again, source and destination IPs. Then we have the quick section here. And then within this section, we can observe that we have packet length, header, destination ID length, source connection ID length, then the payload, which is often an important thing. And over here, it's encrypted from the start. We can see there's a crypto frame here. So this whole thing is already encrypted and secured. So no one can see it essentially. And frame type is ping for authentication. And here we can see that within this crypto frame as well, you have the TLS 1.3 record layer. What this means is that it's encrypting the message that is being sent to the server. And if I just expand this one, it says handshake protocol client hello. So it sends the hello message to the server so it can send back the packet. And then what I will just do is move into the acknowledgement section here. So now I'm moving into my acknowledgement message here, and here we can see that the message that was sent is acknowledged by the server, and then the required web page is sent as well. And we can observe that it just took one round trip time, we can say. And in case of TCP connections, this is usually three or sometimes more messages. So we can see that how efficient this whole thing was. So yeah, this is the overall practical side of things that we have here. And what I would often say here is that TLS handshake happens inside the transport layer, unlike TCP where TLS is a separate layer. We just observed here, and Quick achieves these connections much more faster. And yeah, so the key in order to inform about the key takeaways as well, Quick is much more faster, more secure, and better suited for today's mobile and cloud environments than TCP. Other than that, it represents a major shift in how we think about internet transport, and combining everything to best of UDP speed and TCP's reliability. with the HTTP 3 now built directly on QUIC, it's becoming the new modern for web communication. So yeah, thanks for watching my tutorial. I hope it helped you understand the power and potential of this whole thing. So yeah, thank you.